Now that you're here, let's talk a little bit about selective attention. The human brain includes over 10 billion neurons and 10 trillion synapses, which form networks and subnetworks of unfathomable complexity. However, depending on the job at hand, one neuron can perform several functions. Selective attention is an example of contextual neuronal regulation, which is required by the primate's visual system's hierarchical organization. Latter-level neurons are likely to have several inputs in their receptive areas, and selective attention gives a way to specify what will and what will not be represented. Reynolds, Chalazi, and De Simone in 1999 discovered that neurons in the V4 part of the occipital lobe respond to both successful and inefficient stimuli on average. When one of the stimuli is attended to, the brain reconfigures itself to change the neuron's response. Physical salience and contrast within one or more feature dimensions are two categories of elements that influence perceptual selection. E.T. and Koch in 2000 suggested a model of stimulus-driven attention capture that emphasizes the function of local feature contrast in directing attention. Top-down selective attention is a voluntary behavior that is determined by the organism's behavioral goals. Recent research has focused on two related elements of selective attention: the impact of selective attention on the amplitude and coherence of sensory representations in visually responsive brain areas, and the sources of top-down modulatory signals. A clear separation between purely sensory neurons and strictly goal-related neurons is unlikely